Hi everybody, it's Mrs. Dunn. We're talking about truth tables today. We're going to construct truth tables for negation, disjunction, conjunction, conditional, and biconditional statements. So mathematicians use truth tables to talk about the truth value of a statement for every single situation. So what a truth table does is it shows you every single possible outcome. So when P is true or Q is false and R is true, all of those different situations need to be represented in our truth tables. So we're going to start simple. We're going to start with the negation. Remember, negation is the not. The English word would be not. So, for example, if we have a simple statement P, which is true or false, those are all the scenarios for P. If we have one statement, either P is true or P is false. And then this truth table is showing the negation of P. So if P is true, the negation of P is false. If P is false, the negation of P is true. Okay, that's negation. Now let's talk about disjunction. Disjunction is the or statement. Now before we get to filling out this column, I want you to look at what is represented here. There are 4 different scenarios. You could have both P and Q being true, P being true and Q being false, P being false, Q being true, P being false and Q being false. Do you see that I'm trying to show, or what these truth tables show, is every single scenario, every single thing that could happen. Okay, now let's get to the truth table for the or statement. So I'm using an example. Suppose I say that P is the statement, I own a cat. Q is the statement, I own a dog. Then P or Q is the statement, I own a cat or a dog. So when is that going to be true? Well, it's certainly true when you own both a cat and a dog. It's true if you own a cat but not a dog, because the statement is saying, I own a cat or a dog. Well, you own the cat, so you own a cat or a dog. Same thing here. I don't have a cat, but I do have a dog, so I own a cat or a dog. That would be true. So all of these are true. The only time it's false is if you don't have either. So this is the truth table for the disjunction. True, true is true. True or false, true. False or true, true. False or false, false. A disjunction is true as long as one of the statements is true. One or both. Okay, let's do conjunction. Use that same example, and it's an and statement. I own a cat and I own a dog. Well, it's certainly going to be true for the first case. I own a cat and I own a dog? No, because you don't own the dog. So this is going to be false. I own a cat? No. False. I own a cat? No. I own a dog? No. False. So for the conjunction, the truth table looks like this. The only time it's true is when both statements are true. Otherwise, it's false. All right, this one seems to trip people up a little bit. So let's think about this. This is the conditional. This is the if-then. So let's take these statements. You do the dishes. You can play video games. Let's put this in an if-then statement. If you do the dishes, then you can play video games. So think of the different scenarios. If you do the dishes, then you can play video games. You do the dishes. You're allowed to play video games. Was this statement true or false? It was true. You do the dishes. I don't let you play video games. I lied to you. This statement would be false. You'll see this on the next screen. How about this? You don't do the dishes. You do play video games. This is what trips people up. This statement would be true. You don't do the dishes. You don't play video games. It's true. Let me show it to you on the next screen. So the truth value And the truth table for the conditional statement looks like this. It's true all the time unless the promise is false. So the promise is if you do the dishes, you're going to get to play video games. The only time that statement is false is if the first part is true and the second part is false. Think of it as a false promise. It's a lie. I said that if you do the dishes, I'm going to let you play video games. You didn't do the dishes, or you did do the dishes. I don't let you play video games. I lied to you. So that's the only time the statement would be false. Make sure you study this one, because a lot of times students want to say that this is false, but it's not. This is a true statement. You don't do the dishes, you still get to play video games. Okay, the promise was if you do something, I'm going to let you do something else. So if you carry out your first part, I have to carry out the second part. It doesn't matter if you don't withhold your side, the first side. Okay, I don't know if that makes sense. Think about that a little bit, but this is what the truth table looks like. Okay, lastly, you have the biconditional, an if and only if. So it's you do the dishes if and only if you can play video games. Okay, or you can play video games if and only if you do the dishes. In this case, the biconditional is going to be true when both P and Q are the same. So if it's true and true, the biconditional is true. If it's false and false, the biconditional is true. Any other time when they're opposite each other, the biconditional is false. So the biconditional statement is true when both sides are the same, both trues or both falses. Okay, so those are like the rules. Those are like the rules of the game. So now what we're going to do is we're going to play the game, and we're going to look at a compound statement, and we're going to use these rules to determine the truth table for a more compound statement. So putting it all together, construct a truth table for the statement Q or if P then not R. Notice this has 3 statements. So first of all, to construct this truth table, we need to have 8 rows as opposed to 4. We've added a statement. We have P, Q, and R. So all of the scenarios are listed here. Remember, that's like where P is true, Q is true, R is true. P is true, Q is true, R is false, etc. going down the line. Notice there are 8 different scenarios. Every time you add a letter, it's going to be 2 to the number of letters you have in the problem. So 2 to the third would be 8. That's why we have 8. If there were 4 letters, it would be 2 to the fourth. You're not going to see any with 4 letters. The most we do is 3. Okay, now, how do we put this in the truth table? Every one of these statements gets its own column. So notice I put Q, or I don't need a column for the parentheses. So P, if then, not R. Okay, and now I'm going to start to fill in this truth table. I'm going to do it one little piece at a time so you see how it works. Remember from algebra, that idea of order of operations. Maybe you heard of please excuse my dear Aunt Sally. You do what's in the parentheses first. So we're going to work inside the parentheses first. So I'm going to label up here in this yellow row. These letters are numbers, are going to indicate what I did first. So first I'm going to fill in this column. So all that is transferring what was in P over here. So that's just the P column repeated. The second column I filled out was the not R. So here's the R column, and I wrote the negation of R. So it's true, false, true, false, true, false, true, false. So over here it's false, true, false, true, false, true, false, true. I did those 2 columns first. First this one, then that one, working inside the parentheses. Now those 2 are going to feed into the if-then column, the conditional, underneath the arrow. And I put the conditional truth table up here for your reference. So remember this truth table. So P is true and R this column is false. So true, if and only if false, sorry. True, if true, then false. If true, then false is false. If true, then true is true. I'm looking at this. True, true, true. True, false, false. True, false. True, false is false. So that's false. True, true is true. False, false is true. False, true. False, true is here. True. And false, false is true, and false, true is true. So if false, then true is true. So right here you have the truth table for the conditional part of this compound statement. Next, I filled in column 4. Column 4 just requires me to rewrite the Q column. So true, true, false, false, true, true, false, false, true, true, false, false, true, true, false, false. The last column is this column of the OR statement. Here's the OR truth table for your reference. So when Q is true or false, and let me not say the Q part. Let's say it's true or false. That statement is true. True or true. That statement is true. False or false. That statement is false. False or true. That's true. True or true. That's true. True or true. True. False or true is true, and false or true is true. Remember, for the OR, the only time you're going to get a false is if both sides are false. So the only time both sides are false is right here. So this column is all trues except for that one. And that's the answer column. All right, good luck. Remember the rules. Have those listed on a sheet of paper sitting next to you while you're doing your homework. Good luck to you.